All right, so we're doing a second lesson on percent proportion, and that's really just to, number one, nail down some potential quirks that happen when we're doing things with percents, and also to talk about a couple of applications. So same concept, where we've got the part over the whole, and we were using part and whole, and we had those colors, and then we said the percent number was going to be green. Now you can use whatever colors you want. I'm just trying to stay consistent with lesson 3. So we are also looking for either part over whole or is over of. Now, when you're looking at these first 3, you will notice these are very short. They are not application questions. They're not big involved questions. They're very short and to the point. What is 0.03% of 32.4? So I'm going to break that down. First, I see a percent symbol. I know that's my percent. I see a number next to the word of 32.4. So I'm going to say that's my of or my whole. So it's what is, we don't know, that's our is number, out of 32.4. So that's the whole. So what is out of 32.4? And we're saying what is 0.03%? So we're going to put 0.03 over 100. Now, ladies and gentlemen, 0.03% is teeny, teeny, tiny. It is less than 1%. So we should be predicting a very, very small answer, okay? So we're going to do the 32.4 times 0.03 and the 100 times the x. And the 0.03 times 32.4 is already teeny tiny, right? 0.972. Divide both sides by 100, it's going to get even smaller, moving your decimal point by one place, 0.00972. Now notice not a percent. We already had the percent. We were looking for something that was not a percent. So our answer, like we knew it would be, is very, very small. We wanted a very, very small percentage of 32.4. So don't get weirded out if you have decimals in the percent, if you have decimals in the answer. Decimals happen all the time. Very small numbers happen. The next one, 68 is what percent of 63? Now, when you start labeling, you say, well, there's my is number, there's my of number, and you start to write it out, and you say 68 is goes on top, of 63, of goes on bottom. Some people get a little weirded out, like, whoa, why is it 68 out of 63? Remember we said before, you might have, say, paid $63 for an item to get it in your shop, and you're selling it for 68%. So you're selling it for more than you bought it. That means that when you set this up, X over 100%, you're selling it for more than 100% of the original price. So because our numerator, 68, is bigger than our denominator, 63, we should predict the answer is going to be more than 100%. So 68 times 100 equals 63 times x, and I did not set it up by mistake with the x on the left side. So 6,800 divided by 63 is 107.94, and I had to round that, so it's approximately x. But don't forget, the thing we were looking for was a percent. So x is approximately 107.94%. So very important that we double check. The thing we were looking for was a percent, so our final answer needed the percent symbol. All right, last kind of quirky thing. If we want to find, say, 500% of something, in the jewelry industry, pieces of jewelry are an emotional purchase, and they are often marked up by a lot. So 500%, there's our percent symbol, of what number is 30? So we're saying 30, our is number, 30 is the part. Okay, so that's going to go on the top. So 30 over x, and it's 500%. So notice 500% bigger than 100%. Numerator bigger than the denominator. When you finish, over here, 30 should be bigger than the answer you get because the numerators are bigger than the denominators. So 30 times 100, 500 times x. 30 times 100 is 300. Divide both sides by 500, and we're going to get x equals 6. Again, not a percent. We weren't looking for a percent. And 30 on the top is bigger than the 6 that goes on the bottom. So that does stick with our prediction. All right, so here's an application question. A photographer wants to change the size of a photograph they've taken. The original print was 8 inches by 11 inches. That's a standard size picture you're going to hang on your wall. Let's say it's a, senior portrait. She wants the new sides to be 25% smaller than the original. How much does she want to take off if each side is going to be 25% smaller? So we actually need to do the problem twice. We're trying to find 25% of 8, right? Because one side is 8 inches. We're also trying to find 25% of 10. So out of 8, we want 25%. And out of 10, we want 25%. So we're finding out how much are we taking off. So 8 times 25. I actually can do that one in my head. That's 200. And x times 100 is 100x. Divide both sides by 100. X equals 2. That means we are taking 2 inches off. Take 2 inches off. Okay, that's our first one. Second one, 25 times 10 is easy because we're multiplying by 10. We just tack on some zeros there. So 100x equals 250. Divide both sides by 100. X equals 2.5. So on this side, take 2.5 inches off. All right, no problem. What are the new side lengths? So we had a side that was 8, and we're taking off 2. So that new side is 6. We had a 10, and we're taking off 2.5. So that leaves us with 7.5. So the new side lengths, it is now a 6-inch by 7.5-inch photo. What percent of the old area is the new area? Now you can see I was sort of leading you in this one. Of the old area, I put of, so that's my out of number. And then I put is the new area. So we need the areas of these two rectangles, right? We need the area of the original. Now the original was an 8 by 10. So the original area was 80 square inches. The new one is a 6 by 7.5. So the new area is 45 inches squared. So that's the old one and that's the new one. So we want to know what percent. All right, so this is interesting, right? We took 25% off one edge. We took 25% off the other edge. A lot of people would assume that the new picture is 25% smaller. Not the case, which is totally, totally interesting. So is the new area 45, that's my is on the top, of the old area 80, and we want to find the percent. So 45 times 100, 80 times x, and we would divide both sides by 80, x equals 56.25%. What we're saying is the new picture that's only 45 square inches, the new picture is only 56.25% of the original. It went down by way more than 25%. So if you want to know why, and I think this is really interesting, we reduced the length of something by 25%. We reduced the length of something by 25%. This one is talking about area. Length is one-dimensional and area is two-dimensional. So this one actually got 25% smaller and then 25% smaller again on the 2 dimensions. So we would say the new area is 56.25% of the old area. Notice the new area is, I've got the word is with it, of the old area. So I really kept the same terminology. All right, so the other application that we have is on the back. If you purchased your traditional St. Patrick's Day boiled dinner all prepared, there would be a prepared meals tax in New Hampshire. Let's say the entire meal was $49.05 when you paid for it at the register. If $4.05 of that was tax, how much was the meal before the tax was added? So all we're asking you to do is go backwards and say, if I walked up to the counter and they wanted $49.05, but $4.05 of that was tax, we would take the $49.05, take off the $4.05 that was tax. The price of the meal before tax was $45. Okay. Have you ever wondered about the prepared meals tax in New Hampshire? What percent is it? So there was a $4.05 tax on a $45 total bill. Can you hear how that's a part out of a whole? $4.05 was part of the bill. Out of $45 was the whole bill. And if we want to find the percent, we set up that exact same proportion. So 4.05 times 100 and 45 times X. And 4.05 times 100, if I just move my decimal point 2 places, I get 405. Divide both sides by 45, and you get X equals 9. Now look at what we were finding. What is the percent of the prepared meals tax? So X is 9%. New Hampshire charges a 9% prepared meals tax. So if you've ever gone into Price Chopper and you've bought one of those pizzas where they've got the crust and then they put the sauce on for you and they put the cheese on for you and they put the pepperoni on for you, and then you bring it home and bake it, that's a prepared meal. They've done something to it. But if you go into all of the aisles and you buy the crust and you buy the sauce and you buy the cheese and you buy the pepperoni and you assemble it yourself at home, no prepared meals tax. Just something to think about for your future. See you in class.